It would be best to start off with describing, well, what is TipTheWeb? And if this thing works. So with TipTheWeb, what we're trying to do is enable an idea of community-supported web publishing. And what we mean by this is all these people are out online now creating content. People are uploading videos, they're putting up photos, and they're giving all this stuff away for free. And if there was some way that people could financially support the efforts of these publishers voluntarily by giving small amounts of money, we think that this could really change the way people are using the internet. And I think this picture here really describes what we're looking at. It might be hard to see, but there's this street musician playing, and in passing, there's a guy walking by and dropping $1 off or some change in his hat. This is a totally voluntary thing, and we thought if we could bring this idea online with the idea of as you're browsing the web, you're finding stuff that you like, that's entertaining, that's helpful, you could tip it, let's say 25 cents, and continue on with your browsing and try to be less disruptive, but still be able to give feedback to the publishers and say, hey, this is the content that you're publishing that I like the best. And so TipTheWeb is also a nonprofit organization, and so we do not charge fees for people using our service, and we feel that if we're enabling the service for you as a blogger to be supported by your readers, that we should too be tip supported. So people can tip TipTheWeb, and that's the main way that we're going to cover operating costs and have salaries for ourselves. So I think probably the best way is to show how the app is actually working by demoing it, and that way I can use that as you guys can have a mental reference of how TipTheWeb is working, and then I can talk about how we're using YUI 3 and YQL, and but first show you it running. So let's see. So I just have to mirror these displays. Okay. So let's see. This is just the landing page for TipTheWeb. But so now imagine I'm online just browsing. I have a few tabs open here, and I'm reading this post by John Gruber about how to go flash free on the Mac. I went ahead and actually did this. So I really like this post. This was pretty helpful.
Enough money.
So I can say, oh well, yeah, this is pretty good. I'll tip it 10 cents, and now continue on my way. And then I'm on YouTube, and oh, I guess you can't hear the audio, but there's this chicken techno video, and I thought this is just pretty funny. I really like that this guy spent all this time building this video and posting it on YouTube. So 25 cents, I think, is a good tip for this. And so I found all my photos on Flickr. They're all Creative Commons photos. So this was the photo from a few slides ago. And so I would like to encourage this person to keep posting their photos up for free, because I thought this was really great. And I could tip this photo 50 cents. A utility that I use when working with YUI is Dave Glass's YUI Get utility, which just makes it very easy to work with the different YUI projects and using Get, kind of masking all the Get crap that you have to do sometimes. And so I really like this project of his. So let's maybe give him 5 cents. And so now. So I've made all these tips. I've just been browsing. It hasn't been disruptive to my browsing at all. It's basically like bookmarking the site, but assigning an amount. Now I can come back to TipTheWeb, and let's see, go to my account here, and we can see these tips that I just made. And if we look, like, okay, the one to went to daringfireball.net. That makes sense. If I wanted to edit this tip and change the amount to, say, 20 cents, I can do that. The YouTube video now, this actually went to Unicorn Hunters, which was the YouTube account who published this video. So that seems correct because the tip shouldn't go to youtube.com. It should go to the actual person who published it. So I can go ahead and so these are my unfunded tips. I can actually go ahead and let's just fund this one. And now I've actually assigned money to it, and it shows up in this list down here. And I actually already tipped this photo before, so I can go ahead and cancel it. And so what I'm trying to show here is like this user interface that we've built here, all built on YUI, has a lot of moving parts going on. There's multiple widgets. This purple thing at the top allows you to create new tips. This is a widget here to deal with a list of tips, and similarly down here. And I have this these requests all going out to the server, and then stuff moving around on the page, and trying to manage all that. YUI was a great framework to be able to do that for us. And then if you notice, things like these tips to GitHub, they're actually going to the user account on GitHub or Unicorn Hunters on YouTube. And what's important to realize here is like this tip to this YouTube video doesn't have Unicorn Hunters in the URL. So we have to process these URLs for every tip that comes in, and we do this on YQL. So I'm going to dive into how we go about building these types of interfaces where there's stuff going on, a lot of stuff going on, and how we do it in such a way that is a maintainable code base that we can come back to later while we add new features. And then also how we're actually processing these URLs to pull out the interesting data that we can add to the tip so that it's going to the right place. So let me switch back here. So for the first part, I want to get into how we're using YUI 3. And I think we're doing some interesting things that may be useful to you. So I figured I would share. We take our code and we package it up in these little modules. And what we do is we actually have 56 custom YUI modules on TipTheWeb, and that includes our plugins and submodules. And we really embraced the way that the library modularizes code and did the same for ours. But that leaves you with issues that now you have all these little pieces of code that you have to then put them together in some meaningful way on an interface. And then also you have to deal with loading these modules. It would be crazy if I had 50 script tags on my page to bring all these modules in. I only need like some of them at some times and some of them on other times. And what you would usually have to do is combo load these. And these aren't hosted on Yahoo's CDN. They're hosted on our server. So we did have to implement combo loading to be able to handle this type of thing. So with these web app UIs, there's a lot of parts that are moving that have to be in sync. And we realized this early on when trying to build out our pages. And we came up with this idea of having a top-level component. And what I mean by a top-level component is something that's at the page level, like so the tips page that I was on, where I was funding a tip, editing a tip, that sort of thing. That whole thing is one of our interface pages, one of our main ones. And we have a component that's actually a YUI module as well, at the top level there, managing the communication between the widgets, doing the calls to the server, managing the interactions between the parts of the page. And what we use for this, which is very convenient, is Y.base, we extend the base class. Is everyone familiar with the Y.base class? The like widget extends base. But what it gives you is these attributes. And on the server, there's certain information that the server knows about the current running environment of your app that your client code doesn't know but needs to know. Like, where should I be doing AJAX requests to? Or what's some interesting data about the user that I need to know to run the UI? And we use attributes for this because it's great. You can just construct a new top-level component and pass in what's effectively a JSON object of attributes and all their values. Another great thing is being able to have custom events. We can describe the interactions between the widgets on our page with custom events that are named meaningfully for what's actually happening in our application. And we also ended up creating this base class extension, base component manager, and I'm going to talk about that later. But that basically gives us this idea of components and some help around them for managing the instance creation of widgets, and I'll get to that later. And also Y.resource. Both of these modules are in the gallery, and Y.resource is our RESTful wrapper around I/O. So to go deeper on this component manager, it's a base class extension, and you can think of this components object that it adds is a way for you to define statically the widgets on your page, the conceptual functional parts of your page, and you can really think of this as similar to attributes. I modeled it off of that same type of UI. But what it gives you is dependencies. It helps you load dependencies on demand when they're needed. Like, a user clicks on a button and I need to show an overlay. I can go download all the code for the overlay at that time and then create the instance of the widget and show it. And what that helps is for the initial page load to be much quicker. We were able to really reduce down the amount of code that was running on load on our pages and not creating a bunch of widget instances for things that the user may never actually need. Like, I could go to the tips page 9 times out of 10 and never cancel a tip. And so do I really need to load up the overlay that supports canceling the tip? Well, no, I can just wait and do that when it's actually required. And then the interface to doing this is to using a component is similar to the Y.use, but you specify a named component that you've predefined in the components object statically. And then you're provided with a callback. And so when the callback is called, it's past the instance of an overlay, and all the dependencies have been loaded and the instance has been created. And I have a code example here where I have this component that I've named my overlay. It requires overlay and gallery overlay extras, and I have an initializer that will actually create the instance of this overlay. Now, in my code, when I actually need to use it, say there's a click on some show button or whatever, I can say use component my overlay and then provide a callback. And when this is passed into my callback, it's been guaranteed that the dependencies have been loaded and that the instance has been initialized. And so the first time you would run this, it would have to go download the dependencies and call the initializer, but then subsequent times it would be just very fast because the instance is already there on the page. The other thing that we've seen ourselves doing on all of our interface pages is we had the same pattern that we were going over and over with communicating with the server. And our server is pretty RESTful. We wanted to speak HTTP with the server and do so in a convenient way for us. And we were always communicating back and forth using JSON. So we wanted to create something that made this easier for us. And this is where the Y.resource module comes in. And it has more RESTful HTTP semantics. We use HTTP methods. We do use delete. Like, when you want to cancel a tip, we are calling into the server with the delete method. and we use status codes appropriately so that we can communicate what's going on. Like the server can respond with certain status codes, and the UI understands those. And the other main thing we wanted to do was when we make a call into the server, say we're posting a new tip to the server, I wanted to just deal with JavaScript objects and arrays in my code and just pass that off to the resource, and have it automatically translate it to JSON. And similarly, when I'm getting a response from the server with JSON, I want it to give it to me in an object or an array. I didn't want to have to keep doing this entity body translation with every single request. And the other main thing is we were really modeling resources that exist on our server, and we ran into a problem where for I/O, your events are either per request scoped or they're globally scoped. But we wanted something different too. We wanted something in the middle there. We wanted something resource scoped. So then things can listen to events on a particular resource. So every time a new tip is created, let's have something listen for that and then increment the unfunded balance amount on the page. And an example of what this looks like is I'm creating R, which is a new resource with the path, and this there's a placeholder here for ID. So then when I actually go to use it, I can say r.get and pass in parameters, and so these parameters will automatically substitute ID out of the path here. And if the ID substitution wasn't specified there, it would just add it as a query string parameter. So there's just some nice convenience around passing parameters to these requests. And then on success, I'm given an event object E, and E.entity is something that has already been, it was JSON that was already been parsed, or this also works with standard form post bodies too. But this way, my data is already ready for me to use. I don't have to call JSON parse, and it was just much more convenient. So that this module is also available on the gallery. It's lacking some documentation, which I should probably do at some point, but it is there, and it's pretty interesting if you dive into the code. The other thing on TipTheWeb is we were using a lot of overlays, and we were doing this to keep our interfaces clutter-free, but still allowing interactions to be completed on the pages without taking you to a different page. And the way we were dealing with this was hiding things in overlays until they actually needed to be used. So we ended up developing some extra plugins to overlays to help do the things that we needed to do that YUI didn't have already. And also, our overlays are perfect examples of where we're using the component manager to manage the creation of these overlays only when they're needed. So overlay extras is another gallery module that has these three plugins, where there's an overlay modal plugin, which does the thing where it masks the page, and if the user tries to tab off the overlay or click outside of it, it pushes the focus back on the overlay or dialog to give like a modal thing that the user has to interact with. Keep aligned was we were noticing when you're resizing your page, the overlays were moving all out of place. So I developed this plugin to help keep the overlays aligned to where you initially align them with page resize or scrolling or something. And then auto hide is a plugin that helps where you can say, oh, if the user clicks outside the overlay, I want it to hide, or hits the escape key, I want it to hide. So that just gives some of those functionalities. And this is all bundled up right now into one gallery module, but it probably should be broken apart. There is just some limitations with the gallery and submodules. So, but it's pretty lightweight, and there's not that much code there, but it's very convenient to use. So the next part I wanted to get into is how we're using YQL. And we're actually using YQL to process our most important data, which is URLs. TipTheWeb works completely off of URLs. To create a tip, all you need is a URL and an amount. And we wanted to do that so we could work like the internet works and also not require people to already have been integrated with TipTheWeb before you can start tipping their content. So I wanted to look at some of these URLs and see progressively see how they can get hard to actually process useful data out of them. So we can start with my blog, 9to5HTML. I'm the only one who publishes on it. So it should seem pretty easy. We can just take the domain out of the URL that's being tipped and provide a mechanism for the publisher of this content, me, to come to TipTheWeb and claim my domain by either doing a DNS record or a meta tag on my index page or uploading a file. Seems pretty straightforward. Anytime you want to add your site to Google, Yahoo, or Bing, you have to do these types of things to claim you own these domains. So this would be pretty straightforward if that's all we needed to do. But we realized that a lot of people don't own their own domains, that there's a lot of people out there who are publishing content online, and these are like normal people, not geeks, but they're doing it on these platforms. They're publishing on Flickr, say, their photos. And in this case, okay, it's Flickr.com. We can recognize that there's a tip coming into Flickr.com. Let's see if there's like I believe it's an NS ID or a user ID for Flickr. And there's clearly one here. So that would be easy enough to parse out and make sure that the tip goes to this Flickr user account and not Flickr.com. Okay. But then it gets a little trickier if it's a user name. Now we have some processing to do that we actually have to make web service calls. We have this name, F. Wilcherkiss, and we need to really get the NSID out of this because people can change these usernames. And we basically need the canonical username. So we have to make web service calls for this. And this gets progressively harder if you have something like YouTube. YouTube video, all we have is potentially a video string, which gives us no clue about what user account is actually creating this. And even worse, what if we get a short URL in? We have no idea what this content is or who published it, so we have to figure this out. So we call this processing targeting tips. So we need to figure out information about the content being tipped and who should be the rightful person to get this tip. And these are some of the services that we've already integrated with. Things that you can tip, and these are all popular services people are publishing on, and they have really good APIs for us to hook into. So I wanted to go over an example, the hard example, the Bitly one. So if you copied a link off of your Twitter stream and went to go tip it, you would give this to us, and we would now have to start doing some processing on it. And this is all happening in YQL. We built a bunch of custom tables to be able to process this stuff using YQL instead of having our servers do it. So the first step is to determine if TipTheWeb, if we've done an integration with the domain here, Bitly, and then gather data about the URL and cache the results in YQL and return them. So that way, if any other people are tipping the same URL, the results come back super quick, and they don't have to do all this processing. We have our main table that everything goes through is called this target resolver table, and so we just select all the data out of it where the URL equals this Bitly URL. Now, inside YQL, inside our table, it's going through a bunch of steps, and all of our tables, we just basically use the XML to wrap our execute statement for all of our JavaScript. How many people here are using YQL and have written their own tables? Okay, good. So the first thing when we're processing this, and our JavaScript code is going over this, we check, does Bitly, the domain, match one of our integrations? No. Okay, so we're going to have to request the page and kind of dereference this URL. So we have another table which we delegate this task off to a document resolver. And this is a wrapper around the HTML table in YQL where we're doing some extra stuff to figure out if redirects have happened. And so we realized, yes, we were redirected. We were redirected to a YouTube URL. So we kind of then recurse on this, but only once, to see, okay, well, now we know this is actually a YouTube URL, so let's reprocess the YouTube URL. So we check, well, does YouTube match an integration that we have? And it does, great. So we have, we're using the YQL storage to make this very performant. So we just say we have a JavaScript file that represents our integration with YouTube in the YQL storage so it can be loaded very quickly. So now the second step is, okay, so we know what URL we have to gather some data about it. We have to figure out, well, is this a video on YouTube? Did somebody just type in some random string that isn't actually a video? And whose user account on YouTube actually published it? So to do this, we check to see if it matches the video URL, and it does, so we can easily parse out the video ID. YouTube actually has a lot of different variations of video URL, so that part was somewhat tricky. Now we realized that we have this video ID string, so let's query the YouTube videos table on YQL to pull out the title of the video, which is some interesting metadata about this URL and the content, and the author, which is the person who actually published it, where the tip should be going. So once we do that, we realize that that's a valid video URL, and we can pull out this title and author data and have it conveniently to pass back to our server. And then what we want to do is we right now we're just caching these results, which I'll get to later about how we're caching things in YQL and how you can control how aggressively YQL caches your results. We're caching it for an hour, and then we're returning this type of data to our server. The real link that is resolved, the title of the video, happens to be that chicken techno video, and Unicorn Hunter's YouTube account who actually publishes it. And so a lot of requests were made here, a lot of internet requests, web service requests. These would be things that normally you would have to do from your servers. And Dave, my business partner, was a little bit leery of wanting to make a series of web service requests for every tip that was coming in. So one of the reasons we pushed this work off to YQL. And so the first thing that happened is the bit.ly URL is requested, and it was redirected to YouTube. So the HTML table actually goes and grabs the HTML for that page. We then loaded up our YouTube integration file. This is super quick because it's in the YQL storage, loads super quickly. And then we made a web service request to Google's GData feed to get information about the actual video, the content. But so we could have just had our servers call into our YQL tables and make these requests, but we also didn't want to do that. We didn't want to have our servers making just even one outbound request for every tip that was coming in if we didn't have to. We figured, well, why couldn't we just let the browser do it? Everyone who's making the tip, their computer, their browser can go and make these requests to YQL and then tell us what the data is. So that's what we did. And when you have like these thicker clients, when you have frameworks like YUI, this is made really easy. We have one set of URL processing code that we wrote that's in YQL, and we can access it from the browsers or the server. And this allows us to offload the requests, and rate limits kind of become a non-issue. We don't have to worry about our server getting rate limited if we're getting a lot of tips coming in because it's spread amongst all the browsers. They're doing the YQL requests. And also with the caching that we're implementing, we're making sure that if some link got very popular and a bunch of people were tipping it in a row, that YQL wouldn't be doing all this work for each time it has the cached results. So it frees up a lot of resources on our end. And calling this from YUI 3, I don't know if people have seen, but in 3.2 there's a new YQL module, and what it makes a really nice wrapper around calling into YQL. And I was kind of Dave Glass's guinea pig on this. He was writing this module and having me test it out, and I was making sure that. He was making it really easy to use, but I had him make sure that there was a way to get underneath the hood and actually query YQL with all the different parameters and stuff that you may need to, like HTTPS, maybe need to query it with diagnostics turned on or off. And so this module is really great. And it's very simple if you want to use it very simple. Provide the query and a callback. And it's something like this is what it would look like for us. We're querying our YQL tables from the client. We're just selecting all the data star from our target resolver table where URL equals some URL and have a callback, and now we have the results. And we can send those along with the tip back to the server. One of the things that came up is time, and time in two ways. There's being fast and having fast request times, and there's also timing out. So I wanted to talk about those two. Caching helps you be fast, and caching has helped. We were able to force YQL to cache things the way we wanted to so that our results could be returned fast. Because we can't have the browser sitting around waiting while these requests are going on. We need them to be quick. And some of them are doing multiple requests out to web services on the internet, and that does take some time. So one of the interesting ways you can cache it is when you make your call to YQL, you can specify a max age that you can say, I want the cache to be no older than this long, or this allows you to give some control when actually making the request. But how a lot of the ways we're using it is in our tables, in our execute command on our tables, you're given this JavaScript runtime environment where you have a response object, and you're able to set the max age there. So we can say we want this response to be cached by YQL for an hour. You could do a day, 10 days, 7 days, whatever. So this is very useful to know because it gives us control over this black box of YQL's caching. The other thing is timeout, and one very important thing is table lock. You do not want table lock. Table lock is very bad, and we got dinged by this, where our main target resolver table, where we want every single URL that's being tipped to go through and be processed, was locked. And this was just locked while we were developing it. And what happens is if your request, I think it's if you have 4 requests that take longer than 30 seconds to complete on YQL in an hour, within an hour time frame, your table will be locked for an hour. No request can be made to it. And this happened because we've integrated with Twitter, and I was testing out just making tips when I was developing a feature, and I just kept pasting in a link that happened to be a Twitter link. Twitter was down, and the requests were taking longer than 30 seconds, and our table was being locked. So this was horrible. We freaked out. We thought that we almost had to scrap this whole thing because of this. But luckily, there's some kind of undocumented things, but there are some ways to deal with this. Again, in the execute environment in your YQL tables where you can write JavaScript, you're just given this request object, global object, and you can set a timeout on it like this. Also, you're given this REST API, and you're able to set a timeout on these calls as well. And also inside of the JavaScript execute environment, you're given this query API, which you can pass a query parameters. Those parameters you can use to replace parts of the query, but also specify a timeout. Once we found out about this, then we were able to implement this, which is our timer class. So at the beginning of our table, we create this timer class, and its main job is to say, okay, I'm going to only allow this thing to run for 29 seconds at the most, because the 30-second limit, give it a little padding, a second padding, and provide a method to get how much time is remaining from when the request first started on the table. And then what we're able to do is we're able to pass the time remaining, the current time remaining, to all the requests that we're doing. So if we do one web service request, it starts off with 29 seconds. The next one starts off with maybe 28 seconds. And then like if you hit one like Twitter and you say, hey, Twitter, here's 28 seconds to complete. If it can't complete, then your table just quits and returns and says no results were there. And we just mark the tip to needing reprocessing. And that way, we quit before we hit the YQL 30-second limit and timeout. So this was the best way we could come up with to prevent table lock. On the forums, if you look, there's people talking about creating multiple versions of your same table, naming them different, and that is just messy. This is actually what we wanted to do. And we can control now. We can say, well, if this is taking more than like 10 seconds, that's way too long. Like we need these things to happen in like 500 milliseconds or less, and they usually do. But this way we're prevented from having our tables locked for an hour. So just to wrap up, some of the things that we've realized here is that using YUI3 and YQL, we're just a two-person team, but it's enabled us to actually do some very hard things that a few years ago we wouldn't have been able to do, to build super rich UIs and have like all this data processing happen on YQL that we don't have to implement. We don't have to implement caching of these requests, and it's been very helpful for us to be productive. This realization that having these top-level components in your interface to manage your widgets on the page, to do your communication, has been a great pattern for us and has allowed us to have a consistent way that we approach these interfaces that we build. And when using YQL, remember that you can control the caching and deal with timeouts in a good way so you don't get locked out of your table, and use the browser. Use the browser to make the requests. It's just sitting there not doing anything. You can have it make these requests. It's great. And so just to give you where we are with TipTheWeb, we're currently in an invite-only beta, but we have this code that everyone can use, YUIConf, and that you will be able to actually sign up for it. And so everyone who has a laptop, definitely feel free to sign up, and we're looking for all the feedback we can before we open the doors for everyone to sign up. And you can find tiptheweb.org, and you can find me on Twitter at Eric F, and I will take any questions. Yeah.
Wonderful idea with the timing thing. That is really one of the best things I've seen for YQL so far, with the timing function that you.
Yeah.
What I also ran into from time to time, especially when JavaScript gets complex, that it used too many instructions on the server, on the YQL server itself. Mm-hmm. Did you run into that as well? Did you have some workarounds for that?
Well, so the one thing we knew is we were going to have this ever-expanding list of integrations that we have to do. So we basically provided a lookup table to domain to a storage URL on YQL to load in that code. So we're trying to do the most minimal amount of work possible in our main table, and then delegate the work off to an integration. So that way we're not checking, like, does this match YouTube? Does this match this integration? And we're not running through all this processing. And we haven't hit those types of limits yet with the instructions. And we don't seem to be anywhere close, like a few orders of magnitude lower than what I believe the limits are for the execution.
Cool.